Hello, welcome to Math 1960-301, Calculus 2, Summer Session 3. My name is Noon Tenny, and this is part of Lecture 1. In this part, we will solve problem that we couldn't discuss in the first part of the lecture. So now we want to find the area of the region enclosed by the graphs of f of x, e to the x, and g of x equals to square root of x between x equal to 0 and x equal to 1. First of all, to find the area, we discussed earlier that to find the area between two curves, we use this formula. A is equal to integral from a to b f of x minus g of x dx. First, we don't know what is f of x and what is g of x. Usually f of x is the function above and g of x is the function below. Okay, so first we want to graph these two functions, like, we sketch them. So first, say when we plug in 0, so f of 0 it's equal to 1, f of 1 it's equal to e. For the other function, g of 0 is equal to 0, and then g of 1 it's equal to 1. So if we were to sketch this function, we're going to get a sketch like that. This is my x-axis, and then this is my y-axis. At 0, this function here is going to be 1. Function f of x is going to be 1. And then the other function at 0 is we're going to get 0. So the other function is going to look like that. So this is the area that we want to find. It's the area that we want to determine. Zero to 1. So we want to find our integral from 0 to 1. What is the value of f of x? Value of f of x, as we saw it there, is equal to e to the x minus x raised to power of 1/2 dx. All right, so a it's equals to e of x e minus 2/3 minus 1, okay, minus 1. So that is equals to e minus 5/3. So that's the final answer. Problem number 2. Determine the area of the region enclosed by y equals to x squared and y equal to square root of x. So again, at this point, the only difference between this example and the first example is that we don't know the point of intersection. So the first thing we're going to do right now is to find the point of intersection. I'm going to use a different one. So here I have x squared equals to square root of x. X to the fourth equals to x. So to find the value of x, is x cubed minus 1 equals to 0. So x is equal to 0 or x equals to 1. So these are the point of intersection. First, we can either graph these. Okay, if we graph it, so we're going to, we use our graphing calculator. We're going to find that the first function, which is x squared, has the following graph, and then the second function has the graph that looks like that. So at this point, that is your x squared, the square root of x. So since we know which function is above which, we can apply the formula that says a is equals to integral from a to b of f of x minus g of x dx. So here f of x is the function that is above. So we will do our integral from 0 to 1. The function that is above is the square root function, x raised to the power of 1/2 minus x squared dx. Then when we do the integration, x raised to the power of 3/2 divided by 3/2 minus x cubed over 3 from 0 to 1. That is going to give you 1/3. Okay. Find the area of the region enclosed by the graphs. The first function is f of x is equal to 10x minus x squared. Second one is g of x is equal to 3x minus 8. First of all, we want to find the point of intersections. So we have 10x minus x squared equals to 3x minus 8. So that is going to be x squared plus or minus plus 7x plus 8 equals to 0. X squared minus 7x minus 8 equals to 0. X. So here minus 8 plus 1, x is equal to 8 and x is equal to negative 1. So if we graph this, we're going to get a function that looks like this. You can use your graphing calculator, and then so the first So the point of intersection, they intersect at -1, and the other function intersect with the other function at uh, 8. So these here are the point of intersection. So -1 and -11, and here 8 and 16. Okay, so this is 5 here, it's x, and this is y. So the integral is going to be like this. Integral from -1 to 8 of f of x at this point, or the function that is above, it's going to be equals to 10 x minus x squared minus 3x plus 8 dx, and that should give you integral from -1 to 8 of -x squared plus 7x plus 8 dx. That should give you 243 over 2. Okay, so we do the last example. Our last example, we want to find the area of the region enclosed by the graphs. So first we want to find the point of intersection. I have y squared minus y minus 2 equals to 0. So point of intersection would be this point. So y minus 2, y plus 1, y is equal to 2, or y is equal to -1. So at this point, so we can actually graph this as follows. Now we know the point of intersection, we can graph it, and then we do our integral to determine which one is left and which one is at the right. So the one that is in the rightmost function would actually be would be our f of y. Okay, so at this point the graph should looks like this. Just excuse my drawing a little bit. And the function looks like that. And the point of intersection is 4 and 2. Point of intersection here is 1 and -1. So this function here is actually in the right side. So since it's in the right side, we would apply our, so this is x, and then this is y. So we're going to say the area is basically equals to integral from -1 to 2. So the first function is y plus 2 minus y squared dy, and we're going to get 9 over 2, which is 4.5. All right, that concludes it.